So you implement this DHCP and NAT, and there is something called access control list, filtering the packets. If you implement everything on routers, probably router efficiency get degrade. Okay, instead the router efficiency is degrade, the complete network performance will be degrade, right? Because everyone will be sending, but your router cannot be forwarded in a very fast rate. Then obviously that will affect your network performance. We should plan in such a way where we should not give this functionality to be taken care by a router. Instead, we make them a separate host to be provide this service. Okay, so you can think. Okay, similarly, what we discussed NAT and something called access control list. Access control list is something what we define set of rules and we traffic will be and all other traffic will be denied. So that is what access control list. So we have something control over access and we define them in a set of rules. So that is what we call as list. Okay. So this kind of basically does by did by another separate called firewall. Okay. So this NAT and this access control is completely now will be taken care by a dedicated device. We call them as firewall. Okay, that device will do this what you call NAT installation and as also packet filtering. Similarly, this should not be used if your network is very small. I think you're dealing with 50 hosts or like even minimum less than that. Then you can think of to implement this on the same router because router can handle such is with something 1000, 2000, 3000, 4000, something we should have a specific device which does this service. Okay. If you implement routers, I think it's something more burdening your router to do all such specific. Okay. So then you have to understand the frame format because this is what the whole is needed. Have a complete message format from an application layer to the whole concept. So you know, right? So this is completely application layer message format. What are all the fields that here it is included, and what is each field will be represented of? Means what is the responsible of? Okay. The first one is it is also a 32-bit field. Okay. So first is something called opcode. We call them as operational code. So this will be identified whether it's a request message or a replay message. Means this is a message which has been sent from a client to server or from a client to server to client. Okay, that is what an operational code. And we have something called hardware type. So hardware type, so it will understand whether it's an Ethernet or any other hardware like could be a virus or something like that. Okay, that will be used by the second field, which is of how many bits? 8 bits. First is also 8 bits, here also 8 bits. Then here it tells the length of the hardware address. So length of the hardware is something, it could be a MAC address. Okay, so it is nearly 48 bits. We know that. So here, how many bits we have? It is something nearly 16, then 8 bits we have. Okay, something we used to put that in a form of commands. Okay, and we have something here h count. Here it defines the op counts this message could travel. Okay, so probably it depends on your networks. Okay, and how that network you form. Probably if you have more routers like nearly hundreds like that, so 100 routers in your organization itself, then probably your op count minimum it should have been 100. Okay, something like that, defining the packet, how much of that packet should travel. Okay, that is what you call op counts. Okay, and there might be a chance when more than one host will be sending a request to a DHCP server. Okay, in order to distinguish each of this request from one another, so we have something called transaction ID. So transaction ID is something randomly taken by key clients whenever they were requesting to the server. Let us say one, as I am is my laptop would be one client. They are using an address and something and 1001 probably another client, if they are requesting, they can use 1002 or 2001, something like that. With the help of transaction ID, where a server will understand each request will be completely different or independent. So it will not conclude that both are requests from the same. It will distinguish with this transaction ID. So both were the different requests from two different hosts. So that's why the transaction ID is okay. The next field here, which is 16-bit, which is something called time elapsed. So the number of seconds since the client started to boot. Okay, time elapsed is something at time. I think which between your client and the server. So which within that time elapsed where your this complete process has to be complete. Otherwise, your client itself it get assigned with an invalid range of IP addresses, which is starts with 169 dot something. So that is always whenever you see an address in your host which is start with 169 or something, it's actually what it tells that it fails in allocated with the proper IP address. Means there will be no communication between your client and server. So in that time, so your client it get automatically assigned with that invalid IP address, which is 169 dot something. So that is what here the time define. Something called flag bits. The flag bits here to define. So which type of IP address that you need. Which type of address you should allocate it with. So most of the time we use something called unicast. There sometimes it is whenever you want to some kind of okay. So some so kind of one source who hosting this service like on like video, or there might be a group of participants where there will be multiple source. Because here if you take our example, so I'm the host now, I'm hosting this video, presenting my slides and all, and you are all like something a receivers. Okay, group what I here, it's a group of recipients. They were streaming this the data only one copy, but what in so what is the like the traditional implementation? I should send this video data stream to each one of them uniquely, right? Uniquely means it's one-to-one, unicast communication. Instead, when come multicast communication, it will completely reduces the network load by saying to one stream of data. Okay. Otherwise, what should be the bandwidth that I should have in our the broadband? So how many were connected here? Like 40, 45. Let us take 45, and let us assume this data going to be 1.5 MB per second for each of the user. Think of multiply that bandwidth into the number of users. That is a minimum bandwidth that my browser should have to do this communication with everyone. Think you have a multicasting. So what here it's only 1.5 Mbps. It's only to do this kind of like something video conferencing, because the communication is multicasting. Instead of sending everyone with an unicast, so what happens when I host this? Okay, so where a Google Meet server is there, right? So that will create an address, a multicast address, and when you all connect to that, where your broadband, okay, you are requesting them to your broadband to find out what is that address which I hosted, and from there your routers will connect it to an that multicast. You are all being joined to that multicast address. So after once you've been joined, so only this group who are all added, only they were receiving what I'm hosting here. means what the data I'm hosting. So this is what we called as multicasting. So instead of doing an unicast type of communication. So that is where here we used whether it wants to be allocate a multicast or a unicast. And there is something client address. Client IP address initially it will be all 4 octets becomes in 0 because I don't know what is the address of mine, so that I should send within 0. And your address is something what filled by your server, and initially it will also be a 0. Okay, I'll set to 0 if the client doesn't know it, and client IP address will be sent by your server as you send a request first. Okay, then there is something called server IP address, is the what is the actual IP address of your server. It defines the IP address. So whenever my server, I just give all information. Whenever sending a configuration to a client, I should put what is the gateway address of yours. Similarly, the client address. So here, with the help of 32, yeah, it is how much? 32 bits. 32 bit plus 8, it is something 40 bits. So client hardware address. I choose to have the hardware address of your host machine. Okay, and here server domain name if such any, so you can put it here. So this length if you take, probably you will get 48 bits. Okay, so that is where you will be lagging. Like here one line would be of 32, probably next line what it might use, it will be the rest of the hardware address. So then the boot file name, it's something 128 byte file name holding by an extra information, and we have another field called option field, and this field itself tells that it's optional, so it will not be used every time. It is an optional field. It only used at some specific cases. Okay, so what here is whenever anybody can connect it, like your mobile phones, anything. So we will be having all this information about your client. Means our DHCP server will maintain your hardware address. Okay. So and easily I can check who is connected and what they were doing. I can easily identify if somebody will search some movies to download. I can easily find out who is they were doing it, because I will be having all these addresses as they were connected to our network. So I'll get your address and I will assign an IP address, and I could even trace what type of traffic, means what you are searching in your network, everything I could trace. So there were such kind of tools, so where individually I can trace what they were searching and which destination they are looking, like they were connected and they were doing transaction, everything I can able to trace them. Okay, because is what an IP address assigned by me only. How I would assign, I will take some necessary information from you, and this address will never change. It is permanently, right? So later I can do, if I found that some untraffic that like you are accessing, there is itself I can block. Okay, so that even that will be available in every broadband now. There is
Your
some
voice is breaking, sir.
filtering based on. Hello.
Yes, sir.
Type chat box. Chetan G. Okay. Now it's audible. It's clear now. It's still breaking or yes? Okay. Uh, so that is what complete information that will be wrapped in your DHCP message. Either it could be from a client to server or server to client. See what the different DHCP messages were there. Okay, there were nearly 8 different messages. So we just call them as discovery message, offer message, request message, decline message, acknowledgement, negative acknowledgement, release, and inform. Okay, so these are all the different DHCP message. By seeing that message type itself, you could understand what type of DHCP message type is, right? Discovery, Dora, you understood, right? So this is a simple scenario. So how a client can discover this as our newly connected network, how they were discovered without knowing its IP address and all, and how they get assigned an IP address from it. Okay, one more thing here is this application, DHCP application, it's use UDP delivery protocol. Okay, since it's an unreliable, okay, it need not to be get acknowledgement for everything. So it's something called UDP as a transport layer protocol. Okay, so let's say when any new device to a network, what is the first step to get an IP address? It doesn't know what is an IP address like I should use, because everyone who's an private IP address. I don't know on all these three groups what I have, what I made that to be in group, private group. I can use any address, any block of address. So that block should be known, right? So then you cannot get any, even if you know the block and which IP from that block, it's something like confusion because somebody might already use that address. Okay. So what your client will do, so he'll send a discovery message. So in this network is anybody who's present to provide this service, which is a DHCP service. In the DHCP service, what it will provide? An IP address to me, which I can use, how long I will be connected to this network. Okay, and DHCP allocating an IP address based on lease. Okay, some duration of time that will be given to someone to use. After that, that IP will be recalled back by the server itself. Okay, even after if you use, that will not be valid, means you will not more connected to a network. That's it. So when it's sending a DHCP discovery message, so what all it puts, it only puts the transaction ID. It will be randomly generated by a client. Okay, and the source port number and the destination port number. Since 68 would be using as 68 and 67 will be used, your client will always listen. So both the client server will listen and send at these two ports only, 67 and 68. These two ports are used for DHCP process or DHCP application. Okay, and these two were a well-known port number. This will be in the range of 0 to 1024. Okay, so what will be the source port address? Source port address is as the client address. It will put it as 0.0.0.0, and the destination address, since it doesn't know who will provide this service, it will simply broadcast this discovery message to everyone. So if any new system will connect to our network, so your device would also receive this DHCP request message is sent by the device, but your device will not give that service, right? Because your device is simply, it will not want to simply discard it. Okay, so that will be sent, or somewhere that discovery message will be received by your server, and server will prepare response to it. That is what you call DHCP offer message. Okay, it'll put the same transaction ID, and here it will define the lease time. Okay, what was the longest time that you can use this address? Then client address as T, and it put its offer here in the your address. Okay, in this your address, I will put what is the IP address to you to use, which is 181.14.182. And it is also put this its address, which is server address, which is 181.14.16.170. And it will put now, it should be the which port, 67. Whenever they were sending, the sending port of that is 68. Okay, and the source address is the server IP address, which is 181.14.16.170, and the destination is going to be broadcasted, because the server would also don't know who is the client, because it is not assigned name. Since it will broadcast somewhere, that it will be received by everyone, but who initiates, only that client will understand this. So they will receive it, So then you'll send I'll take this transaction as same, and I'll use the release. I'll agree with your release as well. I'll agree with this IP address which is changed client address, and I'll keep your address as empty, and the server address as 116.170. And I'll put the same address as source address, and the destination address as is actually here. I have written broadcast address. Instead, it will do a unicast by using whatever server IP address. Because I don't no more I want this broadcast, because I know where the is an IP address of the DHCP. Then it will do a unicast. As done, send to okay, I agree with your request, your offer. Then I will send request to the just reserved in your pool in the available IP address. And this is what is used by me for some time. Okay, so later it will acknowledge. Okay, you can use. And they will agree, that will send an acknowledgement message back to an client. That's it. So this was the 4 packet would exchange between and host to get connected to a network automatically and assigned with an IP address without using of this services. Okay, so that you may next ask, sir, then why we get an captive portal initially to where I should give an username and a password. So do we done by ourselves, or it's any kind of an security authentication process by DHCP? No. So that is actually what we configure on the firewall to authenticate, because anybody can come and connect, right? If someone who doesn't know, who are not authorized to use our, if they come and connected, so they will also, like DHCP will not provide whether they are the valid users or not, right? What here we did, it's something what, so we will having a database, we'll just collect IP address and your MAC address, and we'll give a username and a password. Whoever who will use that credentials, we allowing them to use our network service. It is something, it's a kind of a simple feature what we have in the firewall, which gives the first level of authentication. First level of authentication is I just wanted to authenticate whether you are a valid user or not. Okay, means whatever the username and a password you will give, with that information, where firewall will help to authenticate you are the valid users or not a valid users. Okay, I just feature, if you know about firewall, I think if you connect to it, so in that you can enable that feature. So it is also kind of an it will be listened in our so you'll give that command like 10.34.1.1:T90 is what redirecting that particular service for authenticate yourself to connect to a network. So before that itself, when you turn on your Wi-Fi, the host will do this job default, getting an allocated. So you will be assigned with an IP address, but you want to access. What will happen? You connected, you can send a packet, but it will go to my router. But from my router, that packet will be getting dropped because you will not authorized. Because there is a wall in. So how we implement here is, so we implement. Let me draw you here. Okay, you can see. So this is our router. Okay, on this router we have something called firewall, and this is what the firewall is. Okay, and this firewall is what is connected to internet. So you are all connected here. You are in this LAN. Okay, so this is your internet. Let us say cloud. Okay, or Wi-Fi or something. So you'll assign with an IP address. You are now sending a package to a router, but a packet comes here. Okay, it depends. Either you install your firewall, which is facing towards an WAN, or you may even install that inside your LAN, facing towards your LAN. That depends how you install. Okay, for that you have some kind of rules and strategies to decide whether you should install in this way or in that way. Okay, as you install, your packet will be forwarded. Even router would also forward, but as it comes here, your packet will be getting dropped. because in this firewall I defined a set of rules that, so first, that is you should be authorized, means you should be authenticated yourself, and later here I written again set of rules which are the website cannot be accessed and which are the website they can access. Specifically I define here is, so which are all the specific like host I should not access, they should not access, anybody should not access. I'll write all this deny statement first, and the last statement I will write them as all permit. Okay, except this set of rules, if any traffic comes to any other network, I just tell them to permit. So what will happen is this access list, what I've written, it will be executed in sequentially. So what are all the deny statement will write? First check, is any of the traffic which is matched to any of the statement which are written, it will drop it there itself. There will be no such traffic that rules you written, so where it will be for some other traffic or some other network, so then it will permit. So then it will forward that package to go to internet and get back a response. Okay, so this is how we used to do that. But you are connected, but you should first what? You should authenticate yourself to use, means your packet will not be forwarded from this base in the firewall. Okay, so that is what the first thing. Okay, it comes. Okay, this is some description about each of this packet, what is exchange between these two clients, get assigned with that, and what is the well-known port number is used here is 68 and 67, and only one well-known port and one MPL port. Okay. The reason of choosing the well-known port 68 instead of the response from the server where client is a broadcast. Okay. So it is always something where these two port numbers are reserved, since one will be sending and one will be receiving, and this would happen between vice versa, as they were sending from a client to server and from the server to client. Okay, so it is something a default process now. Every broadband will give this service like DHCP. It will assign with the private address. Okay, and let me write a finite state machine diagram. This is what the representation of the complete process. Okay, this what actually here which is taken is representing them finite state machine for an DHCP client. Okay, you can also have this finite state machine for a server side, but here we'll just understand what were the states where we have at the client side and how that each state will be changed for a specific event occurs. Okay, so probably you might be knowing Moore model and Mealy model. I think you might studied that in your digital system design, something like. Similarly, here also we have a finite state machine. So initially we should know how many states were there in a client. Initial state, there is something state called selecting, and there is something a state called requesting, and there is something a state called bound. Bound is what? Is the state the client is assigned with an IP address. Okay, after that there might be two states, which is renewing state and the rebinding state. So they were the states of the client. So and that could happens when there might be like whenever this input is there, means whenever this event, when as that after assigning with bounded with an IP address, if the lease time is expired at 50%, again your client should request your DHCP server to renew your time, lease time. Okay, otherwise what will happen? It will expire again. You should do that from the starting step, starting phase, right? So the another one is rebinding. Rebinding, so is something what so after renewing you should be rebind and you should get acknowledge. Okay, otherwise if the lease time is expired, so then you should go with the initial process from the initial state, right? So before you writing this state diagram, you should know how many states were there, okay, in a client side, and what is that each state would represent. You should clearly define what is this each states are. Means initial state is what the initial the starting state of this process of this service. After that, it has something called selecting state, where a state will get in some response from a server for this event occurs. Whenever some event occurs to this, it will be in the state. That state we call them as selecting state. Here you can see, without any event occurs, after you initialize this process by its own, it will send a DHCP request to a server. Okay, what is the output associated with this input event is what DHCP discovery message has been sent, and you will be in the state called selecting, because now you are in the accepting state. Whatever DHCP offers, you will be in this selecting state. Select and so select after request will request like with the offered and given by the server and waiting state what is called DHCP acknowledgement. Even that offer could be cancelled, because if that happens, if you get an action, you know expired. Again, you use a DHCP request to renew. If you get an acknowledgement, you will be bounded. Means renewed time will be used and you will be bounded same IP address. If it is expired more than 75%, is something you will be rebinded by again requesting them, sending requesting. If you get an acknowledgement, then you can bound starting with from the initial step. Initial step. This is what we complete. How you can represent this okay, representing of a process with a mathematical format, mathematical model. So whenever you write in any protocol, I can represent them in two methods. One is formal method, formal representation, and another one is informal representation. Informal representation is so. Anubhav?
Yes, sir.
Audible?
Sir, break ಆಗ್ತಿದೆ sir voice.
Okay. When I disconnected actually.
Sorry, 1 minute ಆಯ್ತಿರ್ಬೇಕು.
ಅದು ನಿಮ್ದು ಫೈನ್ ಸ್ಟೇಟ್ ಮಿಷನ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದೆಲ್ಲ ಕೇಳ್ಕೊಂಡಿರಲ್ಲ.
Yes, sir.
Okay. So there were two methods where you can represent a protocol. One is formal and informal methods.
Sir, present
So
ಮಾಡ್ತಾ ಇದ್ದೀರಾ?
informal method is something. I'm just explaining as it is directly. Okay. Informal method, it's something writing them in an like a flow chart or writing them step one. This is an actually a type method of representing a protocol. It's an informal method. But when you're writing them in a formal method, so we used to write them within some mathematical expressions, or we used to write them with this approach, what is called FSM, finite how a DHCP client process that you can represent. Okay. So there some process will have something called concurrency. Concurrency processes are something what? For specific action, there might be some reaction on the another process. Means there should be a transition also happens in another process. So which we call them as concurrent processes. Concurrent processes means some input what given by one process, there would be relevant an action at the another process. Okay. So how you can design, even if that could also be represented in a finite state machine. So okay, patterns is the kind of modeling of processes. Okay. You can take all this, whatever we discuss, this flow control protocols. So you can write a pattern model. That is what a formal representation that flow control protocol. So if you design that, then pattern model should undergo with satisfying properties. Okay. So probably if you know this area of automata, area of computation, so you will be knowing how that pattern model, how you can design them and how you can verify them. So it is very easy if you model them, and so that is the way that we did, and we were studying them in something. But actually we should be studying them from the approach. So the formal way of studying that protocol. So here we'll just simply and describe the scenario and we will understand like that, because that is informal way, something good to understand than going with the formal way, right? Sometimes we should do that itself. If you in formal way somewhere, you will not understand that they were. Okay, understand with an informal way. Okay. So that itself, like we have a beautiful course on that protocol engineering. That is completely dealing with all this, the formal way, how you can design and how you can verify them, how you can test them protocol. This, and it is mainly on this communication protocol. So whatever we discussing here, flow control protocol, stop and wait, something GB and SR, all these protocols we design them, and with this finite state machine, and we verify them, we test and validate these protocols. So we have one tool called Pragmadev, so where you can use this and you can test that protocol and you can verify that protocol. Okay, it's very easy and it's very interesting too. Whenever if you are coming with your own protocol, communication protocol, if you are like to design, they use this a tool for that Pragmadev. It's something free. We have a community product also, like community version. You can use them and you can install and you can work with that as well. So it is something, a protocol defining the finite state machine. Means in that software, you have to write them in a finite state machine and you have to verify them with an MSC, message sequence chart. How you verify them? Like we verifying them with this sequence message chart only, means this flow diagram, checking them the flow diagram whether they were working with all these different test cases. Okay, so this completes our for third module. From the next class onwards, I will gonna start with your fourth module probably, and then tomorrow